Hello guys, welcome to today's class where we're looking at an example on the distributive property that we previously explained. In today's class we'll be considering a set N containing natural numbers, which is the superset of two variables A and B, which are related by the operations this and the second one asterisk here, where A operation B is equals to 2A minus 3B plus 1, and then the second operation is equals to A squared plus B squared. Now, we are asked to determine if the operation A, operation B, operation C is distributive under set N. Obviously, we know our set N contains our natural numbers. So if I'll be taking it from here, I know that the very first thing I need to do is bring out the two relations that I have, which are what? My A, operation B, 2A minus 3B plus 1, and then the second operation, which is the asterisk, A operation B giving us A squared plus B squared. So these are the two operations we have, but then to show its distributivity, that means we need to analyze the particular one we are given. We are given for distributivity. And this for distributive property, we are told that A operation open bracket B operation C by distributivity should be like an opening of the bracket. It should be like an expansion process. So we say what? A operation triangle B, then we have all asterisk A operation triangle C. So in the distributive property also, as we said in the last class, we'll be considering three variables, not just two. So the distributive and the associative properties require three variables for us to work with, while the commutative and the closure require just two. So for this one now, we need to understand that it is kind of an expansion process where we actually need to show that for this operation is working with our B, and then this same A operation works with our C. So that is what, and then the operation in between both of them now stands as the one between the two brackets in total. So after having this, we can, because this is what we are asked to find, we know that we want to prove that this particular operation is equals to this operation. That is what our distributivity explains. So if that is what we are about to do here, we know the next thing we have to do here is to take out random values, that is random elements of the set N, which are natural numbers. And say let A be 2. Just taking random examples of natural numbers. Let's say A, B is 3 and C is 4. Then I'll need to tell you that for the left hand side now, if I'll be taking the left hand side alone, that is of this particular operation, for the left hand side, I remember that for the left hand side I have A, so this is what I need to prove. Where I know that my A here is 2, so I'll be proving that this is 2, operation triangle, B is 3, asterisk, my C which is 4. I know that before I can work with this, I need to work with the ones in the bracket first. In the bracket here, I know the first one I have in the bracket, I have 3 operation 4. Okay, let me just let's just take the overall view and just continue with it. You have 2, operation 3, asterisk 4. We know for the asterisk operation, we are already given the operation for the asterisk, which is A squared plus B squared. So I can easily say that this will be 2 operation. This one will be 3 squared plus B squared, because our 3 and 4 here are serving as our A and B in this case. So moving further, I know then we have 2 operation 9 plus 16, which is giving us 2 operation 25. And then this operation, for the triangular operation, we remember that the formula for the triangular operation is for the triangular operation, we have 2a minus 3b plus 1. 2a minus 3b plus 1. In which case, 2 here will be serving as our a, and then our b here will be 25. So our 2 here, so for 2a minus 3b plus 1, we know our a here is 2, our b here is 25 plus 1. So now we have broken down this operation into basic operations that we know, that is the subtraction and the addition. And then we'll be having 4 minus 75 plus 1, giving us a total value of minus 70. So this is the left hand side. So this is what the left hand side is saying. Now let's expand the right hand side and see if we'll be getting the same values. Since we are done with the left hand side here, we'll be looking at the right hand side now. For the right hand side, we have a triangular operation B asterisk a triangular operation C. So for right hand side now, we know we have a and we know we took our a to be 2, so this will be more or less 2 operation, our b is 3, our a is still 2 here, and our c here is 4. Those were the values that we assumed for our a, b, and c, since they are natural numbers, that is, they are members, they are elements of the set n. So I can say here that was using the operation triangle. We know that from the operation triangle, we're given the formula for the operation triangle, which is 2a minus 3b plus 1. So from there, we can take it up. 2a minus 3b plus 1. So for this one, I can say for 2 operation 3, this will be 2a, our a here is 2, minus 3b, our b here is 3, plus 1. And now this will be giving me 4 minus 9 plus 1, which is giving me a total value of minus 4. So this is my value for 2 triangular operation theory. So I'm done with the first one. I do for the second one also. My a in this case now is 2 and my b here is 4. So I'll be having 2 times a minus 3 times b plus 1, giving me 4 minus 12 plus 1. My final answer here will give me minus 7. So this will be standing for my 2 operation 4. So now that I have these two values, I can now perform the operation asterisk relating both of them together. That is, I can now say, since I know that my 2 operation 3, 2 operation 4 has now become, since this one has become minus 4, and this one has become minus 7. So I'll be performing the asterisk operation on both of them. In which case, we remember for the asterisk operation that the formula is what? A squared plus b squared. That is the formula for the operation from here. So a squared plus b squared. Our a in this case is minus 4. Our b here is minus 7. So we'll be having minus 4 all square plus minus 7 all square. We are having 16 plus 49, which is giving me 65. So that means my operation A asterisk B, A operation C. It's giving me 65. So this is what the right hand side. So now we can now compare our left hand side and our right hand side values. For the left hand side, we got our value to be minus 70, and then for the right hand side, we got our value to be 65. So you can see, since minus 70 is not equals to 65, that is, the left hand side is not equals to the right hand side. It just implies that A operation B operation C will not be equal to A triangular operation B asterisk A triangular operation C. So since the two of them are not equal, then I can say then the operation A is not distributive under set N. So this is a typical example on how we can actually apply the knowledge of distributivity in solving a particular question. So in the next class, we'll be looking at another example. So do well to actually practice this one very well so that we can understand the principle and the concept that we actually follow through to arrive at this particular answer. So see you next class. Have a nice day.